Recording in progress.
Okay, now let's get started. We'll start with the fundamentals of statistics. Before we begin, let us understand what I cover in these four topics. Basically, I am planning to cover two sections today and remaining two sections tomorrow. Let us see how it goes. Right? Again, it depends on how you grasp these topics. If you grasp it fast, will speed it up. Okay, anyway, initially I will not speed up because I have a mix of people, both technical, non-technical, and non-statistics background people are also there. Hence initially the pace will be a bit slow. Okay. Okay, in section 1, we'll get started with introduction to statistics, and will help you to understand the branches of statistics and the scales of measurements and so on. In section 2, we'll discuss about the descriptive statistics, the branches of descriptive statistics such as measures of central tendency and measures of spread. As part of measures of central tendency, we'll walk you through the business applications of mean, median, and mode, what is outlier, and so on. In section 3, we will visualize the data and understand the different types of distributions, such as the normal distribution, uniform distribution, bimodal distribution, what is skewness, what is kurtosis, and how do we interpret the outliers presence. And also we'll take a look at the position of the data using percentiles and quartiles and so on. And lastly, in the section 4, will help you understand the measures of variability. It is also known as measures of spread. So as part of this, let's take a deep dive in understanding the measures such as range, variance, standard deviation, coefficient of variation, and how to apply those measures in business scenarios. Okay. Now, first thing first, what is statistics? What is statistics? Can someone tell me what is statistics? What is your understanding about statistics? Let's make this session more interactive. Can someone tell me or open up what is statistics? Statistics is a branch of mathematics. It deals with collecting, interpreting, organizing, and interpretation of the data. So initially, let's say you got into a project, right? So the moment you get the data, instead of applying the fancy algorithms and making some predictions, we first try to read and understand the data by applying statistical techniques. So by doing this, we are able to understand what type of distribution the data has. Do we have outlier in the data? In case of any outliers presence, how do we deal with them? Does it really require any treatment? In case of any missing values, do we have to treat them? Your data should be clean. You have the data. Data is the backbone. Without data, we cannot do anything. We have the data, but is that data, whatever we have it in our end, is sufficient or not? The sample given by the customer is helpful for us to go ahead and perform the analysis. Okay, that sample is there, and we need to go and analyze whether given data is sufficient enough, or does it require any cleaning? Is that data, whatever we received, is complete and consistent? Okay, so in simple term, as part of statistics, right? Statistics is a science. It deals with collection of the data and classifying the data, analyzing the data, and interpreting the numerical facts or data, and the use of probability theory to impose order on aggregates of data. As part of data analytics, the simple data analytics, the same process we follow. We collect the data. in the real time scenario, we don't get the data in a single source system. Multiple source system will be there. We need to talk to the customers, stakeholders, key stakeholders, and find out the source of truth. Which source should I use it? Which source system should I use it? For Oracle applications, you are using 3 different RDBMS databases. Which database should I use it? Okay, and right, so and then once you know the source of truth, you need to collect the data and you need to classify them, and you need to do some kind of data cleaning and analyze the data. Once you analyze the data and plotting the data using charts or visuals, the next step is the moment when you look at the chart, it tells you the story. As a statistician, you'll be knowing, right? Even a data analyst, they can make out. So what is the difference between data analyst and data scientist? Data analyst, they know ETL part, reporting part, how to extract the data, clean the data, load the data into the target system. But they don't know statistics. They have a very limited knowledge on the statistics. They don't have much knowledge on statistics. Whereas as a data scientist, you should do the data analysis, and also you need to apply these statistical techniques to gain more insights about your data. Okay, and other thing is the probability theory. Using probability theory, you can make a prediction. What is the probability that the specific instrument in my stock portfolio, which specific instruments can more likely to go, what is the probability that I can sell it with higher probability, or higher cost. Okay, so what is the probability that I can get 80% return or 60% return or 20% return? You can make a prediction with the probability theory. Typical data analyst, he knows only how to clean the data, how to create charts. With that chart, you should be able to, as the price increases, simple example is, as the price increases, the sale is going down. This much you can say. With probability, you can make a prediction, right? What is the probability, what is the likelihood my sales can go high if I increase the price? So it is not, increasing the price is a blanket statement. How much should I increase? Okay, in simple terms, apart from performing the typical data analysis, you can go one step further. By knowing the statistics, you can make a prediction. Apart from this, we have the prediction models like linear regression, statistical models. We call it as a machine learning models like linear regression, logistic regression, and various other supervised and unsupervised machine learning algorithm, and the semi-supervised machine learning algorithm. We can make a prediction about the future instead of knowing the present only, right? So we can go one step further and predict what is going to happen in the future with the help of statistics. There are 2 branches of statistics are there at a high level. One is the descriptive statistics, the other one is the inferential statistics. Let us start with understanding what is descriptive statistics. Before that, let us understand the different scales of measurement or the different level of measurement. Okay, so now the question is, why should I know the levels of measurement? So knowing the level of measurement helps us to decide how to interpret the data from a variable. So what is a variable? A variable is anything that can take on different values across your data set. For example, salary is a variable. For example, you have something called salary. Salary is a variable, right? Age is another variable. So this variable, it can take on different values, right? Let's say in my data set, I have 1 million records are there, the salary can take on different values across your 1 million data set, right? That is what a variable. But if you know the levels of measurement, it helps us to decide how to interpret a data from this variable, from these variables. And also, knowing the level of measurement helps us to decide what statistical analysis is appropriate on these values that are assigned. Okay, whether this variable is a categorical variable, nominal variable, or ordinal variable, or is that an interval or ratio, based on which you decide which technique that you can use it. Okay, so there are 4 different scales of measurements are there. So one is, so we can say variable. Okay, 4 different types of variables: nominal variable, nominal type of variable, ordinal type of variable. We have something called interval and ratio. So what is a nominal type of data? So nominal, right? So in the case of nominal, the data can only be categorized. We can categorize. It is also called as a categorical data. Categorical. Okay, it is also called as a categorical. Even the ordinal is also kind of a categorical. Using nominal, the data can be categorized, whereas in the case of ordinal type of variable, you can categorize the data as well as you can rank the values. For example, give me some example for nominal type of variable. I mentioned very clearly categorical. For example, you have something called gender. In your data set, you have a column by the name of gender. Gender can have male, female. That's all. Okay. So again, you have something called female, male. So some customers write in your data set, listen, order number 100. This order was raised by a male, and 102, this order was raised by a female. So using this categorical variable gender, we can classify the given data. How many number of orders raised by male? How many number of orders raised by female? We can do classification with the help of the gender or with the help of this categorical variable. The gender is a categorical variable. It is a nominal type of variable. So why it is called as a nominal type of variable? Why do we call it's a nominal type of variable? Because so in this case, right, it's just we are labeling the data. You just think that way. Nominal is kind of labeling the data. So for this order, we label them as a male, right? We are labeling this data. In the case of nominal type of data, we use frequencies. How many number of males ordered so-and-so product, or how many number of males ordered in total, how many number of females, how many number of orders raised by female. If somebody is asked, right, it's something like a frequencies. How many number of times the female is occurring, how many number of male is occurring, frequencies. The nominal type of data we can use, right, so we use frequencies, proportions or percentages. What is the percentage of orders raised by male versus female, if somebody asks, right? But in this case, you cannot calculate mean. Can I compute what is the mean? Mean is average. In statistics, we call average as mean. Okay, so I'll be using this term mean only. Try to be used to this term. Okay, so because if you are a statistician or data scientist, you should be knowing what is mean. Non-statisticians, if you tell them average, they will be able to understand. So average is a very simple formula. We studied during our school time. Okay, so using the nominal type of variable, we can classify or categorize the data. The one example is gender. Other example is something like religion, and we have something else called color. Let's say you are selling different brands of cars in your showroom, and also for each brand different colors you sell it, right? So color is a categorical variable. It is also a nominal variable. You cannot compute the average on this nominal type of variables like a gender, color, religion, and you have something called defect type. Another example is something like defect type. If you are a software guy, defect type is severity, medium, low, something like that. Okay, something like that. Okay, so these are all some kind of categorical variable. You cannot do summarize male plus female, female plus. You cannot do that, right? It doesn't make any sense. All right, is there any way if I can? So okay, you might argue with me. Instead of having text values in our company, we do some kind of encoding. What is encoding? Instead of male, we use numeric value 1. Instead of female, we specify 0. Wherever the order raised by female, we flag that records in the gender column as 0. For male, we flag them as 1. So since it is a numeric variable, if I compute the average, which is nothing but the mean, does it make sense? It doesn't make any sense still. Okay, it is just 1 is just a male, it is 0 is a female, that's all. This is to recognize whether this order is raised by a female or male, that's all, right? So here, even if you encode this data with some numeric values, even if you do average on these values, it does not make any sense. Can you say how many number of can you tell me the average number of orders raised by male, right? So if you say the male is something like 2.5, that does not make any sense. 2.15, that does not make any sense, right? So in simple term, you cannot take average, or you cannot find out the standard deviation. You cannot perform arithmetic operation on this nominal type of variable. Okay, there are a lot of examples we can specify. Okay, in the case of stock market, right? So you have something called small cap stocks and corporate bonds. So let's say you have numbers like the derivatives. You have a column called derivatives. You have something called 1, 2, 3. So 1 is small cap stocks, and 2 is corporate bonds, 3 is derivatives. Just to distinguish which funds are related to which type of investment. That's all, right? The next one is the ordinal. Okay, even the nominal type of variable, we use different terminologies. Okay, so we call it as a qualitative variable. It is called as a categorical variable. Some people, they call it a qualitative variable, and some they call it as a non-parametric variable. So nominal is also called as categorical, qualitative, non-parametric. You cannot compute arithmetic operations like a mean and standard deviation. You cannot use it on this column. Only frequencies are possible, and proportions you can find out, frequencies you can find out. You cannot use mean standard deviation, you cannot use it. The median mode, we have something called mode. Mode is something like a frequencies. Okay, only that one you can use it. The same thing is applicable here also. The ordinal is also categorical variable, and it is also called as a qualitative variable. Something like feedback. Let's say you run a restaurant. Once the customer finish their meal, you are asking them to fill in the feedback form. So they give the rating. So between 1 to 5, 5 being the high, right? If they give 4 or 5, that means outstanding. If it is 3, they are not so satisfied, they are okay. One is poor, two is poor. Okay, so this also feedback is also categorical variable. In the case of ordinal type of variable, the values that are there in your variable, right, it stresses the order or rank of the values. That is the difference between nominal and ordinal type. So even the ordinal is also called a categorical variable. It is also called a non-parametric variable. Right, so we can say qualitative variable. All these three terms are still applicable, but the difference is rank. You can categorize the data and also you can rank the values in your variable. That's what I mentioned. The example is feedback. Let's say for simplicity's sake, I take one customer gave me a rating as 5. The other customer gave me the rating as the quality of my food is 4. Other customers gave 4, 4, 4, and let's some customer they gave me 3. In this case, the feedback column is a categorical variable. We can call it as a non-parametric. Don't worry about this term parametric. We'll explain it later. Here, this column has values in terms of numeric value, or you can specify something like outstanding. Like here I mentioned, right? They can specify the text also, right? Text value, outstanding, very good, 3 is good, something like that. But unlike nominal type of variable, in the case of ordinal type of variable, the ordinal type of variable, the values that are there in your variable, right, are ranked. If I say 5 is greater than 4 and 4 is greater than 3, it makes sense. 5 is greater than 4 and 4 is, which means if I get rating 5 from the customer, that means the quality of the food is superior. Here, we can compare the values, right? But whereas here, can I say just because I encoded the value for male as 1, can I say male is superior than female? Female is 0. Can I say 1 is greater than 0? No, right? Can I say 0 is 1? Yes, mathematically this is correct, but when it comes to this, it is not. It doesn't make any sense. We cannot say females are inferior than male. You cannot do ranking here. In the case of ordinal type of the variable, the values that are stored in your variable, categorical variable, are intrinsically has some order in it. That is the difference between these two. Both of them are categorical, nominal and ordinal, but the exact difference is the values that are stored in the variable, in the case of ordinal, right, intrinsically it has some order in it. Next one is the interval. So even in the case of interval, the data can be categorized, ranked, and you can evenly space it. The next one is the ratio. The data can be, even in this case, you can categorize the data, you can rank the data, you can evenly space it, and has a natural 0 here. Okay. So what is the example for the interval? Intervals are distance between two things, right? Two things. And for example, right, so what I would say, let's take a simple example. Or you just think interval is something like so you have something called discrete variable and continuous variable. So I use this example, okay, I use this term discrete variable. Not only me, as we move further, this is the term will be used more frequently. Discrete variable, this is ratio is also called as a continuous variable. Continuous variable. Ratio is also called as a continuous variable. Interval is called as a discrete variable. You just think that discrete variables are nothing but the whole number. Let's say in the labor ward, in the hospital, labor ward, right? A senior staff nurse, when she enters into the labor ward, and if she asks the junior nurse how many number of male kids born, how many number of female kids born since morning, the answer could be something like since morning we have 2 male kids and 4 female kids, or maybe the opposite. It is not like 2.33 male kids, 3.99 male kids born, female kids born, right? We never use these values 3.99 in this case, right? Number of kids born in a labor ward is one of the example for discrete variable. Whole number, it is a whole number. Okay, how many number of defects surfaced? Let's say you are in the manufacturing unit, assembly line, okay, and you are inspecting the number of defects produced or surfaced. When you do the let's say you are a quality inspector, as and when the machines produces the finished goods, it is your responsibility to investigate or test whether the finished goods, whether the produced finished goods are in line with the specifications. Okay, now you are finding some problem. Okay, there are some products were not produced in line with the specification, there are some deviations, so you call it a defect. Okay, how many number of defected products are there produced? You say 3 defected products, 5 defected products, 8 defective. You never say 5.33, 8.33 defective products. It's a whole number. Okay, so these are the examples for the discrete variable. It is a whole number. And the next one is, the other one is age. Other example is age. If somebody is asking you what is your age or your customer age, we never say he is 23-year-old and 23 year, 2 months, 2 days old. We never say that way, right? We tell the whole number, 23-year-old, 24-year-old, something like that. These are the examples for the interval. Interval is something like discrete variable, whole number. So you can apply mean, median and standard deviation on these type of variables. You can use the arithmetic operations. You can perform arithmetic operations such as mean, median, standard deviation on the interval type of variable. So what is the average number of defects produced by machines in the factory, right? In the factory outlet. So in the factory, right? So in that case, we can say in different factory, these are the average defects we received it. Okay, so these are the example. What is the average age of your customer? This is another example, right? So what is the standard deviation? You can find out the mean, median, standard deviation on this type of variable. So interval, if somebody tells you interval means you just think this is a discrete variable. Okay, and what is a ratio? Ratio is a continuous variable. We call it a continuous variable. Please remember these terms will be used. Discrete variable, continuous variable, these terms will be used more frequently. Even during the model building, right? Machine learning model, when we train it, so that time we use this term, continuous variable, discrete variable, all these things. You need to remember this one. Categorical variable also, you remember it. It's nothing but the nominal type of variables, okay? So in the case of ratio, also we can do some kind of categorization, right? You can do some kind of categorization, you can do ranking, we can perform arithmetic operations like mean, median, standard deviation. What is the example for ratio? Salary. Your salary need not to be a whole number, right? Salary, let's say you are getting, your take home is 1,82,023 0.32, something like that, after deducting the LOP. This is your salary. Your salary need not to be a whole number. Another example for continuous variable is the weight. You want to ship your laptop from Bangalore to Hyderabad via a courier service. They will measure the weight of your laptop. Let's say the weight of a laptop is 2.65 kgs. What does it say? 2 kgs 65 grams, or 650 kgs. So 2 kgs 650 grams are there. You cannot round it off. We cannot say it's a whole number, right? If you try to round it off, what will happen? Either if you round it to 2, it is a loss for the courier company, because every 500 grams they are charging some money. Okay, if they round it down to 2, it is a loss for them. If they round it up to 3, it is a loss for you, because you'll have to pay 350 grams money unnecessarily to them. So, in the case of continuous, as the name suggests, continuous variables, right? So it will have a continuous values, 2.650, decimal values will be there. You just think, in the case of interval, it is a whole number. Okay, the ratio level variables have all of the characteristics of nominal, ordinal and interval variables, but also have a meaningful 0 point. Okay, the 0 point is real. In this case, it is not arbitrary. Okay, so if somebody says 0, right, it means 0. Okay, you can add, subtract, divide and multiply the two ratio level variables. Okay, so you can do that way. The 0 has a real meaning here. If I say in my account balance is 0, that means I don't have anything here. Nothing is there with me. Okay, but whereas in the case of interval, 0 has some, right? So in this case, in this case it has a meaningful 0 value here, 0 point. Whereas if I say 0 degrees, let's say you are in a resort. Okay, let's say you are in Kodaikanal or Ooty or Kashmir, right? If somebody is asking you what is the temperature, if you say 0, so if somebody says 0 degree temperature, it doesn't mean there is no temperature at all, right? It doesn't mean absence of temperature, right? So 0 degrees also, right, it tells us something. It means the temperature is very bad. So it's so cold. So in the case of interval, the 0, right? 0 means it's something like an absolute value. Okay, so it doesn't represent the absence of the temperature. Just think that way. Okay, 0 has some something here, meaning here. Here also the natural 0. If somebody says the real meaning of 0 is, we need to go by the real meaning of the 0 here. But here it is something like it's something like arbitrary. Okay, so here the 0 is real meaning in it. In the case of this ratio type of variable, so if I say my account balance is 0, that means I don't have anything. The real meaning for 0 is coming into picture when it comes to this one. But whereas in the case of interval, the classic example is temperature. If I say 0 degree temperature, that doesn't mean there is no temperature at all, right? Fine. So that is what you need to remember it here. So hope you understood the 4 types of, or the 4 different scales of measurement, and you understood the difference between each of them. So nominal and ordinal, both of them are categorical type of variable, but the difference is when it comes to ordinal type of variable, you can categorize the data and also you can rank them. So interval and ratio, interval is also called as a discrete variable, ratio is called um, continuous variable. So in the case of nominal, the data can only be categorized. Ordinal, the data can be categorized and ranked. The data can be categorized, ranked, and evenly spaced. The data can be categorized. All these things and has a real and has a natural zero. If somebody says zero balance in my account, yes, it has a natural zero. Okay, nothing is there. Now, these are the examples. Let's see how many of you can answer. Gender is a nominal type of variable, right? So, can you tell me whether age is a nominal type of variable? What is the scale of measurement? This one. Can someone type it? All of you, please type it in the chat window quickly. What is the scale of measurement? The age. So, gender, I have given an example. Gender is a nominal type of variable. Let's say male, we can specify 1, or female, we can specify 2, or we can use a text value as it is. Male is male, female is female. To distinguish or to categorize the data set, you can use this one. Yeah, age is ordinal. So, age is ordinal. Okay, so anybody else? How many of you agree with Aruna? Aruna says age is ordinal. Is that ordinal? So can I say 23, a customer, has age 23 and another customer has age 24. Can I say customer with age 24 is superior than customer with age 23? Aruna? Just because a customer is lesser, we cannot say, ranking, we cannot do ranking here, right? 24 is not superior than 23. Let's say the total number of orders, we go by the total number of orders. Management wants to know the total number of orders with the age breakdown, right? So they want to see 23, 24, how many number of orders we received it. 24 to 26, how many number of orders we received it. Okay, so just because here there is no superiority. You just think when it comes to ordinal, right? You just think about the superiority thing, okay? Then you should be able to understand. How about Mugilan? Mugilan, the others, can someone else tell me what is age? What scale of measure? Age is interval. Okay. Age is interval. Hours spent is a ratio. Performance rating is ordinal. Very good. So this is the correct answer. The correct answer is age is an interval and hours spent is a ratio because it has a decimal value. See, this is a this is a discrete variable, whole number. I don't know, this is a whole number. There is no superiority comes into picture. When it comes to superiority, then we call it the ordinal type of variable. Oh, Deepak, good that you joined. Okay. Okay, so this is age is continuous variable, hence we call it the interval, right? So I call this the interval. This is your ordinal. Okay, this is a discrete variable. Discrete, you understood, discrete is a whole number and this is my continuous variable. And the next one is gender is it's a nominal variable. We cannot say discrete or continuous variable. Okay, and male 1, 2, even if I say 0 or 1, right? Yeah, so in general we use discrete values only for encoding and all. Okay, next we will take a look at what is descriptive statistics. So as I told you, there are two main branches are there under statistics. One is the descriptive statistics. The other one is inferential statistics. Inferential statistics. Okay. we'll take a look at what exactly descriptive statistics is all about. So what is a descriptive statistics? So it involves summarizing, organizing the data so that the data can be easily understood. So unlike the inferential statistics, okay, unlike in the case of inferential statistics, right? Uh, Unlike inferential statistics, when it comes to descriptive, we just describe the data. We are not going to make any attempt to make inferences from the sample to the whole population. We are simply describing the data. Let's say you joined with a company and you as a data scientist, right? The first step, what you are doing is you are exploring the data. You are conducting the data exploration. As part of the data exploration, what you are doing, you are using the descriptive statistics. Right? You are trying to get the gist of the data. They've given you the sales data, right? So with the sales data, the management wants to know quickly, can you give me, the gist of this data? Last, let's say 6 months data, sales data was given to you. Okay? So they wants to know the gist of the data, summary of the data. So minimum. So that's where the 5-number summary is coming into picture. What is 5-number summary? 5-number summary. Minimum, maximum, and then you have something on median, and first quartile, quartile 1 and quartile 3. So these are called 5-number summary. So what is the minimum sales that we achieved? Minimum sales in the last 6 month data, what we could say, the minimum sales is, we made the minimum sales is 120K. The maximum sale is 833K, something like that. This is the maximum, minimum sale, maximum sale. What is the median sale, average sale we made across the category? Let's say you sell the products under 3 different categories. In each category, what is the average sale we made? What is the minimum sale we made in each category? What is the maximum sale we made in each category? What is the quartile 1 sales value? What is the quartile 3 sales value? Median is the middle value. Okay, with this you will, no matter the volume of the data, right? So even if the volume of the data is very high, getting this information, giving this information is pretty faster, but it takes longer time. If the volume of the data is very high, though it takes longer time. So these are the 5-number summary, you can give it quickly. Right? It doesn't require too much of calculations, right? So complex calculations. You don't have to train your model. You don't have to use any algorithms. With this, you will get a gist of what is there in your data. You will be able to understand the characteristics of data at a high level. Got it? So this is what a descriptive data statistics. There are some other example for, these are the typical questions. Let's say in the case of telecom industry, right? So your management wants to know what proportion of customers have responded to the offer in the data set. What is the average duration of calls? What is the median call? What is the average age of customers? What is the distribution of customers by gender? Right? So what is the distribution of customers by gender? For example, in my histogram, I have something like this. Distribution of customers, right? The distribution is something like this. Positive skewed. Or if it is a normally distributed, normal curve, bell curve, left skewed data, right? This is what I'm talking about. Okay, the distribution of customers by gender, male customers distribution, how many number of calls made by the female customers, male customers, what is the distribution of that variable? Number of calls is my variable, quantitative variable, number of calls made by female, right? So number of calls made by female in the last 6 months, if you plot it, right? So you can see each month, if you take the average and if you plot it, if you get something like this will show you the distribution. With that distribution, you will be able to understand are there any lopsided calls made by the customer, or the calls made in a uniform way, or something like that? Okay, is there a difference in call duration between people that sign up and people that don't sign up? Okay, so by conducting the descriptive analytics or statistics, you should be able to answer to these business questions at an high level. With these numbers, you will gain a quick insight. What is the average duration of calls? What is the median duration of calls? What is the average age of my customers? If you know that, you can better target the right customers. You want to launch a campaign. Okay, if the average age of customers, at least the average of customer is between 23 or 25, they are the one making so many calls. Maximum number of calls made with the breakdown of the customer's age. When you look at that chart, you are able to understand people, let's say 25 to 30 years, right? So that age group, the call duration is very high. Maybe they are working people, they're all in that age group. Most of them are working people. They need to call their home, they need to make calls to office or senior people. They'll be spending a lot of time in status calls. So with the distribution, by plotting their call duration, the distribution will get to know. So are the distributions normal or symmetric or asymmetric? You will get to know that. Okay, there are two types of there are two branches are there within this descriptive statistics. Please remember, in the statistics, two different branches are there, descriptive and inferential. Inferential, I am going to talk later. Within this descriptive statistics, there are two different branches, sub-branches are there. The one is measures of central tendency. Here we are very particular about the location of the data, the central location of the data. The classic example is average. What is the average salary drawn by employees across the department? Right. So the other branches, measures of spread. Measures of spread or distribution. Measures of distribution, measures of spread, right? They use different terms. So we will take a look at the measures of central tendency now. So far we discussed about what is descriptive statistics. In simple terms, summarizing the data and summarizing and presenting the data in a visual format. Okay, summarize. Basically, we are doing summarization to get to know the characteristics of the data at the high level. That is what your summary descriptive statistics. As part of this, there are two branches. We will take a look at measures of central tendency. So we have something called, as part of measures of central tendency, we are very particular about the central location of the data in the distribution. Okay, where the center of the distribution tends to be. That is what we are very particular about. The measures of as part of the measures of central tendency. In the measures of central tendency, we use more frequently these measures: mean, median, mode. These are the measures we will be using it more frequently. So what is mean? Mean is average. In statistics, we call average as a mean. This is the data set given to me. For different data scientist salary is given here. And if somebody is asking you what is the average data scientist salary, okay, forget about this at this moment. And if I ask you to find out the average salary of the data scientist for these 5 records, you will get this value, 48,000. But we have some other value here. One more value is there. I did not consider this one when I took the average of other values, right? I did not take into account of this one as part of averaging all these values. Okay, five records only I averaged it. With this record I could see that 48,000 is the average salary drawn by data scientist. This is what I conclude by taking the average of these 5 data scientists, right? So I can say these data scientists falls under band 4 and level 6. See, in the company, for each when you join any company, right, especially in software company, I don't know other company, okay, so they have something called band and level. So in band 4, level 6, all the employees salary, they recorded it here, including this one. Okay, all these data, let's say or a simple term here, we can say 4 year, all the 4 year data scientist salary in the same company we noted down here. Even though all these 6 employees are having 4 years experience, it doesn't mean all their salary should be same, isn't it? Even in our company you can see the same thing. So you are 4 year experience, when even your peer is 4 year experience, there will be a slight difference between your salary and his salary, right? Fine, but in this case, purposefully I included this data here without considering this one. If I take the average of these 5 employees who has 4 year experience, I can say that the average salary drawn by the data scientist with 4 years is 48,000. But if you see something, the other record here, this data is way too high compared to other 5 employees salary. Now you are wondering, all these 6 guys are having 4 years experience only, yet how come this guy's salary is very high? Now you are calling the payroll department, you are asking him, hey, why this specific employee's salary is very high? If he says, no, there is a typo, you ignore the last 0. You say, no, you ignore the last 0. Okay, we put additional 0 here mistakenly. That means even this employee's salary is also same as, somewhat closer to these guys, other guys, right? But on the contrary, when you call the HR or the payroll guys, if they say, no, it is correct only. So in that case, if you consider this guy's salary is also, while you perform the average, when you compute the average, right? So when you take into account of all these 6 data, and if you take the average, you will get this one. And if somebody else, let's say your friend is working with other company and he is asking you, hey, what is the average salary drawn by 4 years data scientist? I am looking for a job change. If I get into a data scientist role in your company, what is the average sale can I expect it? Will you tell this number or will you tell this number? Which one you will tell? All of you please type it in the chat room. Let us make it. See, if you can't, if you don't concentrate here, gone. Your time is wasted. Deepak Chakri 40,000, Aruna 48,000. Can you justify, Aruna, why 48,000? Why not it is 123K? Because our common sense tells us, just because one person is getting very high salary, and if I include his salary along with others, obviously my average will also get skewed. I use this term skewed. The average will also get skewed because my data is skewed. My data itself skewed because of this one huge value. My data is also skewed. Skewed data. We could see some kind of asymmetry. This 500,000 is called outlier. We call this an outlier. What do you mean by outlier? unusually if you find a very big value, or unusually if you find a very low value, let's say minus 2, 3, 4, 5, 6, or let's say minus 4, 4, 8, something, minus 4, 8, 4, 5, 6, negative value, low value, up, unusually very low value, unusually very high value, or we can say extreme values, right? Right, so in this case we could see both extreme, unusually very low value, unusually very high value, we can see that. So these are called your outlier. If you have an outlier in your data set, we call that as a skewed data. So this 500,000, so look at here. So if you compare, this guy's salary is somewhat close to this one. So though there is a difference, but 48,000 is somewhat closer to 57, but when you compare the 48,000 with 500,000, it is much, the difference is very, very high. 48,000, 500,000, the distance is very high, whereas 48 to 57 is somewhat closer. And if you compare 53 and 57, somewhat closer. 53 and 41 also somewhat closer, but if you compare 41 with 500,000, the distance is too high. Hence we call this an outlier. There is a formula for outlier. Okay. At this moment you just think extremely very high value, extremely very low value is also called as an outlier. Very high value, abnormally very high value, abnormally very low value is also called your outlier. If you have abnormally or unusually very high or low value in your data set, we call it skewed data. With this skewed data, if you use mean, your mean value will also get skewed. So with this, what we conclude? Aruna, why don't you tell what we conclude? Can I use mean in this case? So let's say HR is telling me very clearly, yes, this is a valid data. It is not a typo. This guy is getting 500,000 because he joined from Google and his experience also high. Though his experience is very high, he is okay to fall under 4 years, and his interview performance is very good, and his past career, based on his career track or previous company, right, we went one step ahead and we got approval for this guy. Okay, he is getting 500,000. In that case, you have to include this data also when you perform the average, when you compute the average. But if you exclude it, you are getting this one. It's good. If you tell your company who is working in, or if you tell your friend, right, hey, if you join my company, on an average you can expect 48,000 given your 4 years experience. You will not tell this one. The reason is, here we include the outlier. When we include the outlier, while we compute the mean, the average is also skewed. If you tell this to your friend, what will happen? You are setting a wrong expectation with him. He will be thinking, hey, if I join this company, I can get 123k. It's a very good hike. Better I will apply for this position with this company. But the reality is not this one. Just because one person is getting very high salary, you cannot include that guy also as part of your averaging, and you cannot tell, hey, you will get 123k. You are setting a wrong expectation. So to conclude, if you don't have outlier in your data set, then you can go for mean. You can do the average. If you have a skewed data, which means if you have an outlier, unusually very high value, unusually very low value, then don't use mean at all. We have some other measure, you can use that. What is the other measure? Other measure is called as median. We have something called median. Median is the middle value. Very simple to remember. Look at this data set. We have 3, 6, 9 data points are there. And the rule is, first you need to sort the data in ascending order. Sort the data. If you have to compute the median manually, sort it in ascending order. Okay. actually the you just think this is something like 51. Okay, it's not 11. Okay, 10, 20, 22, ascending order. And then if you look at the middle one, since the number of data points are 9 here in total, right? So sorry, 3, 6, sorry, here 9. Yeah, 9 is there. It is a odd, right? 9 is an odd. So in the case of the odd, right, the sample size is 9 here. So it's odd, right? Since finding the median is pretty simple. Or the other simple way of doing is you just cancel this first value, last value, cancel this one and this one and this one and this one. So you are left with this value. This is your median. Let's say my total number of data points are, how many of them are there here? You have 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The total number of my sample size, you just think my sample size is 10. In this case also the same rule is you need to sort the data in ascending order. Fine, we did it. You say this is also 51 and this is, you just think this is 63, something like that. Okay, so what you do is in this case you sort the data in ascending order, but here the total number of samples is 10. Hence in this case what will happen, the middle, we have two middle values are there. In this case we have only one middle value. It's pretty easier to find out the median. So in this case we have two middle values are there. Okay, so in this case what you need to add these two values, 32 plus 32 divided by 2, so which is nothing but your 32. This is how you need to find out the median. This is the one we studied during school time. Now let us use the median for the same data set. So the same data set I copy paste, sorry. The same data set, one second, let me just. The same data set I copy paste. Ignore the other one, okay? You ignore this one. Ignore this one. The same data set in the previous slide, whatever, right? We have used it. If I compute the average for these values by excluding the outlier, the mean is 47,007, right? If you find out the median for this value, what is the middle value here? If you sort the data in ascending order, what will happen? 38,150. And you have, what is the next highest value? 41,000. And the other one is 38, 41, 48,000 and 53 and 57. Okay, I did not take into account of the outlier. You just think 38 for simplicity. Just 38 means 38,000 and odd. Okay, you just think that. So what is the middle? So I started this data in ascending order. The middle value is this one, right? So 48,670. Okay. So that is the 48,670, correct, right? So the median is the middle value, 48,670, the median. So if mean is, you need to add all the values divided by 5. So when because look here, this curve, right? So this thing, I just put it up to this one only. So if so add all these values and divide by 5, you'll get this one. The next one is, if after including the after including the outlier, my mean is 123k. That's what we have seen it earlier. The mean is 123k. If I use the mean formula, 120. But if I use the median, what happens here, Aruna? When I use median, instead of using mean, if I find out the middle value, it is not gets skewed like a mean. In your data, if you have the outlier, if you use mean, the average value also skewed. It is not the right way of doing it. But when I use the median, even though I have an outlier in my data set, it is not getting skewed. Got it? Okay, so look here. So this is the data, right? So look, where is this one? 38,041, and the last one is 500. the first one, last one, if you cancel it, right, so you have 48 and 53. If you add these two things, for at least 50-50, right, you'll get 50 only, somewhat closer to 50 only. Looks, that's what you're getting, 50,000. So median is so robust compared to mean if your data has outlier in it. This is the takeaway. Yes, we do not get much difference as we get close value. That's correct, Aruna. Hope you understood, right? In the case of skewed data, which means if the data has extremely very high value or extremely low value, better you can rely on median. You can use median, don't use mean. If you don't have any outlier in a data set, then you can go for mean. Okay, it's already 1:32. Okay, so what I will do is, since a few of you have the afternoon office, like 2 to 11, I'm going to wrap up. So this week, tomorrow what we will do is we'll continue with the mode and the measures of spread or the shape of distribution. Okay, so initially we'll have 1 hour duration. Okay, Saturday 1 hour, Sunday 1 hour for the next 2 to 3 weeks. Afterwards, we will increase it to 2 hours. Okay, so Saturday 2 hours, Sunday 2 hours. Only then we should be able to complete it on time, right? Any questions so far? I'm going to unmute you all. So whatever I covered as of now, are you able to follow me? That is very much important. It's a pretty simple one, right? I did not discuss too much. Very basic thing only I covered. Are you able to grasp it? Yeah, she says yes, sir. She's able to grasp it. Aruna was able to grasp. Okay, the pace is initially slow, but as we move further, right, when I start the inferential statistics, it will be slightly complex. Anyway, I'll try to reduce your learning curve. But if you can let me know as and when, right? If you think, if you can send me your feedback, it will be good. Okay. So that we can make a course correction instead of waiting till the fag end. If you think you are pretty faster or if you slow down, study material, all these things I'll give you access, don't worry. This Monday will give you, my website is now up and running after we lost a lot of data due to some crash. Now we are able to restore it some extent. We'll share the login credentials to you all by this Monday noon, okay? And you can go through on all the study materials. We'll share the links, where you can find which document, all the things, including the script, everything, okay? And tomorrow we'll continue the, the second part of the descriptive statistics. Okay, since you don't have any questions, I'm going to wrap up the session now. And still, feel free to send me if you have any concerns or feedback to my WhatsApp, okay?